Okay, so here is the data on the third collision, a completely inelastic collision. Now, it looks similar to the inelastic collision because we have two final velocities. However, we notice the second final velocity is slightly lower than the first. But we know they stuck together, so they were moving at the same speed. It's just we have two cards, and as the first card passed through the gate, compared to the second card, it slowed down due to friction again. So the first data point for the final velocity will be more accurate because it had less time to adjust for friction, so it's closer to being true. Now we look at the initial velocity, 0.677 meters per second, and the final velocity, 0.303. We notice that it's roughly, the final velocity of the carts that stuck together is roughly half that of the initial velocity of cart 1. And that's because their masses are approximately equal. So it makes sense, based on conservation of momentum in an isolated system, that the final momentum should be roughly half if you double the mass. And that is the third collision. So from this, from the velocity, we can calculate on all three experiments, we can calculate the initial and final momentum based on the mass of the carts, which we would use a scale to measure. The mass of these carts are roughly 0.5 kilogram. And we could determine that and see the ultimate test and ultimate goal of these experiments is to see, is momentum conserved? Is mass times velocity initial for the sum of the carts equal to mass times velocity final for the sum of the carts? And that is this experiment.